Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to actually enforce rules when it comes to interfaces. But before we get into that video today, I actually just realized, and this was actually brought to my attention, that we passed 100 videos. So that's pretty awesome. I definitely am happy for everybody who's stuck with me since the beginning. I still see some of you guys commenting around some of the videos, so that's very awesome. And yeah, so thanks for sticking around, and let's hope for another good, successful 100 videos. So another thing I want to talk about too before we get into this compiler is I'm actually taking a hiatus from the programming language. So I'm kind of at a point, this is actually why I'm putting this video out so late today. I'm kind of at a point to where I'm burning out with the language. It's very easy to do that. I actually just looked on GitHub and I've nearly written about 2 million lines of code since the exception of the actual programming language like a couple years ago, which is pretty insane. But with that being said, I am starting to read a book now for the actual programming language, and I'm actually reading, let's see if do I have it up here? Yeah. So I'm reading this book, Engineering a Compiler, and this is my first ever book that I'm actually reading so I can figure out how to actually write a real compiler. Now, I skimmed through like half of the book already, and I'm gonna come back, circle back around, and just like read it page to page. But from what it seems that I actually pretty much have done things in the right way. It basically mentioned that compilers have two parts, a front end, a back end, and an optimizer. And I have all of those parts. And it went into a little bit of detail about how each of those segments work and then the different types of optimizations you can actually do. And you know what, I actually recommend this book. I don't recommend things very often, especially when it comes to books because I don't really read that often too much. But I can see here, like you guys can see that, I mean, it has a pretty decent rating. And I sifted through a couple books, and this one had the best rating that I could find. So this is the one that I'm going to recommend if you guys are curious about doing it. I actually rented mine for like a couple months. I got it for like 20 bucks. So I got mine rented out until March of next year. I should be finished with it by then. So, you can rent it out for quite a few months. And, for 20 bucks instead of paying the, full $70 for the actual book, it's actually not bad. So that's kind of what I did, but let's actually get into the video today. So I'm going to go to compile. And let's see, so now we're still in the post-processing phase. So now what we're going to do is we're going to start talking about how to process delegates in the programming language. So basically what a delegate is, and I'm going to go back over this because we don't really talk about delegates too much in the language. So let's say I create okay, I'm going to keep this class here. Let's say I create an interface and interface of, let's say iFace or something. And let's say this interface has a function in there, do work. And sorry if you guys are hearing like pings in the background. I'm working with other people doing other stuff right as I'm filming this video. So I'm actually going to close that really quick. Hold on. I'll be right back. All right. So you can basically do this. So you have this interface. This is going to implement the interface. And then you have a function that, you just create the function and that implements the method in that interface. Well, today we're going to be learning how do you actually enforce the rules behind this. So I kind of got the way this works in my compiler from basing it off of other languages and how other programming languages work. So let's just kind of go through to see. So what you want to do is you want to create a function called resolve all delegates. Now, because we've already processed all methods, you want to do this after you process all methods because then you can basically do this just fine. You won't have any issues because you'll know that as we're processing this, any classes that implement this interface are going to have those methods in there because, that's just how the flow of the compiler works. So in the resolve all delegates function, we have our usual stuff, right? So we have our for loop, we get our current parser, update the error management instance, get a log of our total errors, update our scope. So we add a new scope and global scope, which will be set down here. So we for loop through all of the branches in the AST. On the first branch, we do our usual stuff where we try to find the module that the user is referencing. And you guys can just copy and paste this. It's all the same stuff. So once you do that, then you want to do a couple checks. So you want to check for class declarations and mutate declarations. And then after that, you want to do your usual error check to make sure we haven't blown over our error limit. And then our final, epilogue or the end of each of our functions. We have the same stuff here where we check to see if we have any new errors. We add the parser and then we remove the scope, and that's it. So once you guys get all of that done, we're going to look at classes first, then we'll look at methods or actually mutates in a second. So you want to create a resolve all delegates function, pass an AST in a current class. And again, remember current class is going to be equal to null because as we're creating our generic classes, we're actually going to be using this on our generic classes when we create them. So once you do that, you want to get the block of the actual AST from the class and do our usual current class check. So you want to pull the name out, try to find it based on the level of scope. So if we're at global scope, meaning that the scope type is global scope, then you want to find the class in the classes list. Otherwise, you get the actual class from the current class and you get a subclass or a child class from there, and that represents your current class. Now after that, you want to make sure our current class is not equal to null, and you want to retain the primary class. Remember, that's definitely important. You want to do that. And of course, you want to restore it once you're finished. You want to add the scope. Now you want to say class scope, and you want to add the class and remove it, at the end, of course. And then we want to call the validate delegates function. Now, this is going to be the bulk of the video. So before we get into that function, let's just kind of go through everything else. So create this validate delegates function. It takes parameters of a class object, which represents the subscriber and then the AST. So what we're going to do is we're basically going to say we have, this class here of A. It's going to implement these interfaces, and we're basically going to say this is the subscriber that is subscribing to stuff inside of the iFace or the iFace interface. So that's kind of the concept. So like I said, we're going to go over that in a second. Once you create that function, then you want to create a for loop where you for loop all the sub blocks or the sub ASTs in the actual class and do the same thing, right? So if you run into a class declaration, you call the same function, resolve all delegates, but you don't pass the class name, so you're just going to recursively call into this function. So you just do the branch here, and then the current class will still be null. Now let's go into actually how mutate declaration works. So what you want to do is create this function. Now you want to do it at the high level first, right? So at the high level, when you call this resolve all delegates function, paste this code here. Inside the resolve all delegates for classes, paste the exact same code in there. Once you do that, you create a function where you take an AST as a parameter. You guys know what this is, right? We do this in all of our delegate or all of our mutation functions. You want to try to figure out what is the class that we're trying to mutate. So we compile the reference pointer, we get the current class by doing this code. You can literally just like copy and paste this from like other source code. It's the same stuff. And then you want to, so if we have a current class, if the class is a generic and the generic owner is equal to null, meaning that this is in fact the head class of generics, we do nothing because it's already been processed. Again, we'll see that code later on. All of this source code for like all this stuff, most of this source code is going to be inside of the compile generic class function, so we'll see that later. And then we just call this function resolve all delegates, but this time we pass it the class that we're mutating as the class that we want to represent. And that's it. So that's the entire flow for everything. So now let's actually look to see how we validate delegates in the programming language. So first, once I go into the function, you want to create two lists. So you want to create the subscribed methods and the contracted methods. So the way this works is this works off of a contractor and subscriber basis. So you can imagine this as, and I'll actually make this a little bit more understandable. So let's say this is the contractor, and so let's say employer, right? So let's say I'm an employer of, I don't know, corporation, or let's say ABC Corp, and I want to basically delegate my work to something else. So let's say this ABC Corp is a technological company. So let's say we build software for other companies and we delegate that work to our contractors, and we basically have our contractors do the work for all of our clients. Well, the way that's going to work is, let's say, we have this build app function. So if we have this build app function, well, your employer is going to have an employee or whatever. So like, let's say John the employee is going to implement the stuff that's in the employer interface, and then that basically connects the contract or contract and subscriber pattern. And in order for this to actually work, in order for the employee to actually do its job properly, they have to implement the build app function or do the work that's delegated to that employee that is under the employer. So hopefully that made sense. So if I go back here, all right. So once we create those, then we say subscriber, and then we get all the functions by type. So we want to get all the normal functions from the subscriber. So we're basically saying, employee, give me all of the functions that are inside of your class that you're executing. And we don't do it by name. We just want to get every single function. And we put that in the subscribe methods list. Then we want to basically add all the delegates we need to validate. So now we're basically looking at the contracted methods, and we're saying, all right, employer, give me all of your methods. Now, it's not enough just to look at the employer and say, build app. Let's say this employer was a multi-level company. Let's say, we have the ABC Corp employer as the sub company, and then we have a company above that, or the parent company, called I don't know, DEF Corp. I'm just making up names here, but let's say this has something in there, and instead of maybe build app, let's say this has in there a organize function or something. I don't know. I'm just making stuff up. So then what's going to basically happen is we can have this ABC Corp implement the DEF Corp as a base class. And now what we're going to be forcing the employee to do is to both implement the organize function. Oh, I already copied it, I guess. So I can just do this. So it's going to have to implement the organize function and the build app function. And that is basically the flow of everything. So we don't want to just look here. We also want to look at any base classes that the interface could have implemented. So if I go back to the function, so first, what we want to do is we actually want to traverse the subscriber. So we want to get all of the normal methods of the employee class. Let's say this had a base class of something else. Let's say this had a base class of employee, right? And then let's say this one, so if I do a copy here, let's say this one was the employee class, which had a base class of the ABC Corp. And then let's say this was John, which was JOHN, which basically represents an employee. And let's say for the organize, we call the build app function, which is a reference to one of the functions up here. And then let's say we don't implement the build app function here. So let's say we just say organize and then build app. Then down here, the actual employee of John can then implement the build app function to do the work that it needs to do. So that's kind of the general flow of how it works. And not only that, so because the employee actually implements this, we no longer have to implement this interface, because obviously we're deriving all of that information that the base class has from here. So any interfaces that the base class has, we also implement by virtue, because that's how it works. We're inheriting all of the crap from the previous class. So let's see. So if I go back, so we go through the subscriber, we set the current class equal to the subscriber's class, and we check to see if the current class is not equal to null. We get all contracted methods from that current class. And what that function does is we basically say current class, whoops, so we pass the current class in the contracted methods function. So, okay, so I guess this actually is looking for the implemented methods. So if we go through here, we basically set the contractor equal to the superclass of the subscriber. We get all delegate functions from there. So we're basically saying, all right, John, I want to access the superclass and get any delegate functions from that class. And we add that to the contracted methods. And then we basically for loop through the interface of all of those. Now, the reason why I'm only doing the superclass is because the way it works is it works on a one level basis, meaning that since this employee class is implementing the ABC Corp interface, we basically have one level here. So we have the ABC Corp, and then we have below that. So if I do this and then put a V here, below that we have the employee class. So we want to basically force the very next and nearest level to implement any methods. And any classes after that, so if I have the John class, and I paste this here, so if I have the John class, that class is not forced to implement any of the methods as long as the employee class implements it. If the employee class does not implement the methods here, we're going to immediately get an error. We're not going to just let the employee class ignore it and then have the John class implement it. So that's kind of the concept. So I for looped all the interfaces. I set the contractor here by getting the actual interface at the index from the subscriber, and then I get all the delegate functions from that, and then I basically check the superclass. And if the superclass is not equal to object, basically what we're doing is I'm saying, all right, so I got all methods from this ABC Corp employer. Now let's get all methods from any superclasses that this interface has, and we're going to continuously go up the chain until we're out of interfaces. Because if you remember, interfaces are classes too, and they literally just implement functions, and all the way up to the highest level where each interface is going to have a base class of the object type, because all classes are objects at the end of the day. So we want to go all the way up until we reach the superclass of object, and we want to make sure that it is in fact the object class by making sure that the module is equal to the module of std. So that's what we do, and if so, then we just continuously get the superclass. We run an indefinite for loop, and we get all functions by the delegates added to the contracted methods list. And if the superclass is equal to null, then we break. And that's pretty much it. So once we do that, then we're pretty much good to go. After having all of the contracted methods, then we, so if the current class is not equal to null, we, actually process that. Otherwise, we break. And what we do is we go up the chain. So we go all the way up the chain of every single superclass from John to employee, processing all of those, because obviously any interfaces that John implements are not going to be the same interfaces as employee implements. So, that's the idea. And yeah, so that's pretty much it. Then once we have all these methods, we want to make sure that we don't have any bugs as we're basically processing everything. So what I do is I for loop through all the methods, and I call the compile method return type function. And again, we will go over this function later. This is something that is a little too big for me to talk about right now. But yeah, so we call that function by passing in the actual method and the AST where the method was defined. Now, we're going to compile each of those values, and then if the method is a native, I basically remove it from the contracted methods list, because native functions, so if I say native define foo, native functions are considered delegates, but the difference is that this is a different type of a delegate function, and native delegate functions are handled differently in the system. We'll see that later on, but yeah. So, once we do that, then we for loop through the entire subscribe methods list, and we also want to compile the types on there as well. So we want to definitely make sure we do that. And then once we do that, now we're ready to actually do our actual checks. So in order to make sure that we have in fact implemented all methods in each interface, all we want to do is just check to see if the types are the same, right? So first, we need to check to see if we have the name of the function that we need to implement inside of the class that we're searching. If we have the name, the next thing that we need to check, do we have the same param types as the same thing defined in the interface? Now, this is a very simple type check. If we have organize and we have num of var, well, guess what? The type of organize has to be a num of var. Can't be a num of underscore int 8, even though, yes, technically those are the same types, because they're both numbers, it doesn't matter, right? We need to have the exact type of the parameters matching, so that way we know it's good. Finally, we want to check the return type as well. Now, in this instance, we do care about the return type because we're basically creating models of functions that are inside of interfaces. And then that's it. So that's pretty much all I'm doing here. And so I for loop through every single contract method that we need to implement inside of our interface, and I basically just validate the delegate. So I say validate delegate helper, which we'll get into in a second. I pass it the contract method, or the method we need to implement, and the subscribe methods, or the methods that are assumed to be potential subscribers to any interface up here. And yeah, so after that, if that is not equal to null, so we're going to assign the subscriber function from this function helper, and we'll get into that in a second, like I said. But if that's not equal to null, we check the utype, and if the utype isn't null and the contracted methods utype isn't null, or if they're both equal to null, then we know that we're good to go and we can like make sure we can check types. Otherwise, we say contracted method whatever does not have subscribe method of implemented class. Now, there's a potential that the uType or the return type of the function could be null, theoretically, if the function was considered to be undefined. So if we didn't know like what the type of the return type function is, like let's say I'm returning, this, right? Obviously, the compiler doesn't know what that is. So, there's a potential for that. And yeah, so we want to make sure we do that null check. And like I said, we just say contracted method of whatever does not have the subscribe method implemented in the class. And we want to say what the actual subscribed method is, the full name. We also want to convert the contracted method that we're supposed to implement in the interface to a string. And that's literally going to go through and print out the function in detail of what it was supposed to be. So we'll say, function, and then we'll convert all the parameters to a string. We'll even set whatever the return type of the function is if it is available. And yeah, so once we do all of that, then we report that error and we say note defined here based off of whatever the contracted method is. So not only are we going to print it in the error message, we're also going to physically show them where the contracted method was defined that we missed in our interface. Now, if the flags, right, so we're going to check to see if the contracted flag size is equal to the subscriber size, and they're the same elements. So same elements is literally just a function where I for loop through a list of items, and if the elements are not the same, I return false. Otherwise, I assume they're all the same and return true. So that's a little helper function I did. But if they're not the same, then I say method of whatever provided whatever access flags. So I say access flags to string, which literally just for loops through a list of access flags, creates a string, and based off of that, it just prints out each access flag, which, based off of whatever I pass here, it converts that to a string. And let's see, so if I go back, it says the access flags provided are different than the access privileges of the actual contract method, provided whatever. And yeah, so the reason why we want to do that is because what if you have a private function? So if you have a private delegate function, then that means that we also want this function to be private inside the class that's defining that function. So once we do all of that, then we're good to go. Now, let's see. So if we go back up to here, because I did skip this part, here's where the magic happens and how everything works. So once we basically have determined that we have a return type, if the return type of the contract method is not equal to null and the types are not equal, so I check to see if the type of the contracted function is equal to the subscriber's return type. I said contracted method, I convert it to a string, does not share the same return type of the method implemented in class and whatever the name of the class is. I print out the error and then I also show where the contracted method was defined at in the actual interface. And then I continue on. Now, the magic is right here. So I have a concept of delegate addresses. Basically, what this means is whenever it comes time to actually call this function, what's actually going to happen is, so like if I remove this, let's say I create a new John class. So if I create a, I don't know, J, so let's say this is going to be of type ABC Corp Employer, and I'm going to assign this to a new John, right, which is going to be a new employee. And let's say I say John dot build app. Well, how do I know what to actually call when I call this build app function? What the runtime system does is it says, okay, save the address of this or the delegate address of this function. So the delegate address of this function build app, let's say is 2, right? So let's say this address, if I remove this here, let's say this has an address of 0. Let's say this one has an address of 1. So I guess it will be 1 in this case. We would say, all right, call a function with the delegate address of 1. So then what's going to happen is it's going to look in this class of John, and this build app function is going to have the delegate address of 1. Any other function, so like let's say I define a foo function here. This foo function is not tied to any function in an interface. So it's going to have a delegate address of -1. So that way we know it's not tied to any, function inside the interfaces. So this is going to have a delegate address of 1. That way we know that this is the function that we're supposed to call in place of the actual function in the interface. So that's kind of how it works at the high level, or at the low level, I mean. So yeah, so we'll set the subscribers function, again, the subscribers function, which is this specific build app function. We're going to set the delegate address that it's pointing to the address of the contracted function, which again is the build app, which would have an address of 1. So that's how we make that connection. So once that's done, then we're good to go. Now, if we could not find the function, and we're going to get into the validate delegate helper in a second, if we could not validate the delegate function, then what we'll do is we'll check to see if the subscribers class matches the owner's class. What this does is basically says, does the subscribers superclass match the class that the contract's function owner is? So meaning that, does the superclass of the John class, which is employee, match the same class as, this ABC Corp employer? And if it does, then, obviously that's a problem. So, we'll complain about it. Otherwise, if the subscriber has an interface of the owner. Now, the has interface function is only going to check for the interfaces implemented in that class. So what we're going to do is we're going to say, all right, well, does John have a superclass with this function in it? This is going to be used for, classes or superclasses that have, their own delegate functions defined inside of them. And then we also want to check to see if John has a direct interface implementing or forcing them to implement one of these functions. If so, then, we complain about it. Otherwise, if we don't find the function, then it's totally fine, right? Because the assumption is that we're only going to do this one level after the actual class was implemented. So that's the assumption behind it. And now if it fails, then we'll say contracted method of whatever does not have a subscribed method to implement it in class whatever. So we put the full name of the subscriber, print out the error, and then say as defined based on whatever the contracted method is defined. And that's it. So that's going to be pretty much everything for today, guys. So that's pretty much how you enforce rules when it comes to actually processing delegate functions in a programming language. So hope you guys enjoyed the video today. As usual, if you have any questions, definitely put them in the comment section below. And of course, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.